to make a box. You know how we do it. So we need our calculators. We got a piece of paper that is 10 by 12. We're going to cut the corners out. I got really lazy when I made this sheet. You know what we do, right? Cut the corners out, fold up the flaps. We need the volume of the box to be at least 80. All right? So you know this. What's the volume of the box? Length times width times height, so that'll be what? 12 minus 2x.
Times 10 minus 2x.
10 minus 2x times x. That's the volume, and we need it to be at least 80. So that is greater than or equal to. Now this is like the can problem we did at the beginning of the period. Personally, I'm just going to graph this side and graph this side as a separate thing. I know what that's going to look like. That's going to be something like this. That's going to be 80. If I want to know where the volume is more than 80, it'll be right here, won't it? So I just need to find those 2 points. Now, these are the kind where your x's and y's, you pretty much know what they need to be when you set up your window. Because what's the domain of this problem? What can you tell me about x? 0 to 5. Perfect. And y, the minimum's going to be 0, and the maximum has to be something bigger than 80, right? Like 100 or something. So then it should be no problem to graph this. So sure enough, I get something like that. Oh wow, is that one? That one is 2.76. I want the volume to be at least 80, so how will I answer the question? X is going to be where? In between, and I'll use brackets, because what does at least mean? Well, could be that, right? Could be those. So the volume could be 80 or higher, so these dots are actually closed in. Everybody comfortable with that? It's an exam question, something like that will be on your exam, plus on this test. All right, here we go. Some 12% juice, 18% juice mixed together, you get 50 gallons. How much 18% juice? Anybody remember our general formula for this? Amount, I heard somebody saying it, amount times percent plus amount times percent equals amount times percent. Okay, now we know our percentages, that's pretty easy, we know them. So what are our percentages? 12%, 18%, and 14%. What am I looking for? What's X going to be? What's X? It says how much, 18%? So I think I'll just call that X. I really could call either one of these X, but since that's what I'm looking for, I'm gonna let that one be X. What else do I know? This end amount is 50. I have to end up with 50. So this and this have to add up to 50. Right? So how am I gonna express this? If that's X, and these two have to add up to 50, what's this gonna be?
50 minus X.
50 minus X. Beautiful, beautiful, beautiful. So here we go. I got 16.67 gallons, but I don't know if that's right or not. Let me know, anybody who gets that. Does that seem okay? A mistake that's often made here is when you collect these two terms, sometimes you say 0.6, it's gotta be 0.06, right? Just watch your decimals, you have a calculator, so use it. Comfortable? All right, Rachel takes 3 hours, Emma helps, it takes 1 hour. How long for Emma alone? All right, who remembers the setup for this guy? 1 over alone plus 1 over alone equals 1 over together. So Rachel takes 3 hours. If Emma helps, it takes 1 hour. So that's over here, right? That's together. And we want to know Emma alone. What's our common denominator?
Yes.
So this one needs an X. This one needs a 3. And this one needs a 3 and an X. So X plus 3 equals 3X. 3 equals 2. Did you get 1.5 hours? Did I do that right? Well, we're rolling through these word problems. These are easy. All right, next. It's like we only have one more to go. Word problem. Minimize the size of paper to accommodate 120 square inches of print in the indicated margins. Okay, so what's happening is you have this piece of paper. Don't know how big it is, but we have to have 120 square inches of print in the middle. And then we've got margins of 2 inches and 1.5 inches, 1.2 inches, and 3 inches. So whatever kind of artwork we're doing, making a card or whatever, we're gonna have our writing in the middle and we want this amount of margins around the side. And we wanna minimize the area. So we wanna have the smallest piece of paper we can that will accommodate that. Well, what shape is that piece of paper? Rectangle. And how do you find the area of a rectangle? Length times width. So we just need to know what this is and what this is, and then we'll graph it on our calculator in second calc min. Right? That's it. Now here's the issue. What is that across there? Well, I I know that it's gonna be 4.5, right? The margins are 4.5, plus whatever this is, the width of the print. So I'll call that X. So the width of the paper is gonna be 4.5 plus X. Now, what about the length? Well, I know it's gonna be 3.2, 2 and 1.2, plus this, whatever this is. Well, if this times this is 120, and that's X, what's this gotta be? 120 divided by X, that's exactly right. Now, those of you that are like staring blindly or whatever, let's say that's 120, okay? And let's say I know that this is 20. How could I find this one? If I know the area is 120, and I know that dimension's 20, how could I find this one? Wouldn't I divide? Because 20 times X is 120, so wouldn't I just divide? So that's exactly what we're doing. So this is 120 over X. So the area of that piece of paper is 120 over X plus 3.2 times 4.5 plus X. Now, if you want, you could FOIL that out, but it's not necessary. Because we're gonna go to our calculator and find the minimum. We wanna minimize this, so we're gonna find the minimum. And your calculator doesn't mind the parentheses. So it might be better if you didn't multiply it out, because you might get, well, I guess with the calculator you'd be okay. But there's some arithmetic that could happen. So I'm just gonna put that in. And I am just straight up minimizing it, so I'm just gonna graph it and find the low point. Now, maybe have to, I had to play around with my window a little bit. I know my X min is 0 and my Y min is 0. I know that because X can't be negative and Y is the area and that can't be negative. Anybody find a maximum here to give you a picture? You just need a picture that you can see the minimum of. Anybody find it? What did you use? This does not make me happy. My max was 50 and my other max was 500. Now, there's nothing sacred or magical about those numbers. But when I used those numbers, I got a picture that has a minimum, and that's all I need. I need something that has a minimum, so I got something that looks like this, and here's my minimum. So second calc minimum. So my minimum came out to be 12.99, comma 217.54. Did anybody else get that? Okay. Now we need to answer the question though. So keep in mind what this stands for. What's this 12.99? That's my X. And what was X? The width of the printed part of the paper. And then this is my Y. What was my Y? The actual area. So now what does the question want to know? Minimize the size of the paper. So in other words, we want to know how big that paper is. So this is not the answer. Do you see that? The answer is going to be whatever 12.99 plus 4.5 is, 17.49, and then 3.2 plus 120 divided by 12.99, 12.44. So how big is the paper? 12.44 by 17.49. Those are the dimensions of the paper. Got it? What are the excluded values in this equation up here at the top? I squeezed in some more problems. What are the excluded values? 3, -3, and 0. Excluded values are the things that make the denominator 0. So that I don't forget, I said on this paper, there's everything but one thing. The only thing not covered on this paper is an end behavior asymptote. So I'm just gonna make up a function. What is the end behavior? I'm making this one up. This is like number 12. What is the end behavior asymptote for this thing? How do we figure it out? How do we know? Jake?
Well, 2 would be like your thing, and it would be 3 minus 5 plus 1.
And we're gonna just do synthetic division. And that doesn't matter to us. And the equation that's left is y equals 3x plus 1. So if you were graphing this, you would draw that line, and that would be one of your asymptotes. Okay? Now the reason I needed to add that one on is because does problem 10 have a horizontal end behavior asymptote, or is it gonna be one of these weird ones like this, problem number 10?
Horizontal.
How do we know it's horizontal? Powers match, right? When the powers match, we know it's gonna be horizontal. And not only that, where is it going to be? Y equals what? 1/2. So I haven't done anything yet, but I know that asymptote is going to be at y equals 1/2. Is everybody clear with that? All right, here we go. Let's get this thing done. What do I do to finish up all the rest of this stuff? What? What do I need to do? Factor everything. How does the top factor? X minus 4 plus 3. The denominator, I can take a 2 out. I would do that. I would take that 2 out. And then it's gonna factor. Keep the 2. The 2 has to stay. X plus 3 minus 1. I'm rushing. I want to get this one done before the end of the period. Is that okay with everybody? So before we forget about it, because now we're focused here, But before we forget about it, let's get that hole in. Where's the hole gonna be? X is -3. And then I'll plug my Y in right here. Don't go back to the beginning and plug in your -3 to get your Y. Don't do that. You gotta plug it in right here. So plugging in -3 is gonna give me -7 over -4, 7/8. So -3, 7/8. What else do I have? Vertical asymptote at x equals 1, perfect. Comes from the denominator, x cannot be 1, that would be an excluded value, would be a vertical asymptote. What does this tell me right here? My x-intercept is at 4. X-intercepts make your fraction 0. 4 would make it 0.
And then your y-intercepts too.
Let's see, if I put in 0, I get -4 over 2 times -1. Yep, it sure is, it's at 2. Is that enough to sketch a decent picture?
Yeah.
Yep. Kids, I'm not trying to trick you. I'm giving you a basic standard problem, just like this one. Making sure you know how to find all that stuff. All right, last one, number 11. This one, for some reason, always catches us off guard. How would you start this? What would you do first? I would multiply everything by x to get rid of the fraction. So x cubed plus 3 equals -4x. Is that all right with everybody?
Yeah.
I'm totally programmed to get my equation set equal to 0. This is where somebody's gonna just set me off, because somebody's gonna use the quadratic formula, because it looks like a quadratic thing, but it's not, is it? What are we gonna do if we can't use the quadratic formula? Well, we could, except see the little star next to that one? This is gonna be on the calculator part of the test. So if you wanna try synthetic division, you can, there's no guarantee it's gonna work. What might be easier since I'm allowed to use a calculator? Graph it? And what will I be looking for when I graph it? If I graph this exact thing, I'll be looking where it crosses the x-axis. I would go back to a standard window if I were you. I don't care, it's up to you. But I would definitely consider Zoom 6. And your answer is every place it crosses the x-axis. So second calc 0. How many places does this one cross? 9. So that makes it easy. The answer to the problem is -0.67. We just took the test, all right? We just did every skill that's on the test, okay? We'll review again tomorrow. Different problems, same stuff.